So for 11.5, we're going to go ahead and look at formulas and further applications of quadratics. So here's an example of it's quadratic because we technically have a v squared. It's part rational, part quadratic. But they want us to take this and solve it for v. So we want to get that v down there by itself. But that's not really helpful when it's in the denominator. So our goal here is to actually clear it out of the denominator, clear the fractions like we have before. So since our denominator is v squared, we can multiply by that least common denominator. If I do it to one side, we do it to the other. Okay, so now we have v squared times w is equal to kfr. Getting that v by itself, we're going to undo the multiplication. So it's basically like PEMDAS backwards. We're going to deal with the multiplying before we deal with the exponent. So divide both sides by the w, so that v squared is equal to kfr over w. And last but not least, to get that v by itself, to undo the squaring, we square root both sides. And the key on this one is to keep in mind that because we put that square root there, that square root also gives us the plus or minus. Now we could try to rationalize this, and that wouldn't hurt my feelings, but this is really more of a kind of a physics and a science application. We're going to be dealing with formulas like this in those courses, and so we can have, we're going to be plugging in k, f, r, and w. It doesn't really matter if this is completely rationalized. We do that in mathematics to make it easier to operate with as an equation, but this is going to be your answer here. The plus or minus may not make sense in the context, but since I didn't have any context here, we'll keep the plus or minus. Leave it at that for now. There's another example. We could say that d is equal to the square root of 4a over pi, and this time we're solving for a. This one's a little more complicated to get by itself. We have to, a is being multiplied, it's being divided, and then it's being square rooted. So the inverse, what we do first, we undo the square rooting by squaring. And we do it to both sides. So that d squared is equal to the square root and the square cancel, leaving us with 4a over pi. Still trying to get that a by itself. What I would do is I would multiply by the reciprocal, meaning I want to get rid of that pi on the bottom, so I'm going to multiply the top by pi. But I also want to get rid of that 4, so I'm going to multiply or divide by the 4 at the same time. And what this does is it clears both the pi and the 4 at the same time. If you want to treat that as two separate steps, feel free. But what we end up is with pi d squared over 4, all set equal to a. Here's a word question, application for this. We have two vehicles leaving the same location. One travels north, the other travels west. At a certain time, the vehicle traveling north has gone 20 more miles than the vehicle traveling west. If they are 100 miles apart at that moment, how far has each vehicle traveled from the beginning location? What I find helps with this is we're going to draw a picture. We have a location that they're both leaving from. One vehicle is traveling north, the other vehicle is traveling west. And at one point, the vehicle traveling north has gone 20 miles more than the one traveling west. That more than means we're comparing to the vehicle that's traveling west. So we'll call the vehicle traveling west about W, and that north is 20 more than that. So rather than call this N, rather than have two variables, we would say, well, this is really just the value that west went plus 20 more. So the north is basically what? 20 more than the west. And at this point, if I was just to take this instant, the distance between these two would be a diagonal distance, would be 100. Can we now solve for W? Well, we have a shape here, right? We have a right triangle. And with any right triangle, we can basically utilize the Pythagorean theorem, which is what? A squared plus b squared equal to c squared. where the A and the B are the legs. So W squared plus W plus 20 squared equals the hypotenuse 100 squared. We can distribute this, so we have W squared plus, do not make that W squared plus 400. You need to take the time to distribute that. You get W squared, 20W and 20W would give you 40W in the middle. 20 times 20, how about 400? And 100 squared would be 10,000. So let's clean this up. We have 2W squared plus 40W. I'm going to go ahead and set this equal to 0 by subtracting it over. And I believe that's going to be, a negative 9,600. So what do we do here? Well, I could run this through the quadratic formula. Heck no. I don't want to sit there and do, these are much bigger numbers than I want to deal with. You could do that, hit enter, and you get your answer, and that's fine. But I'm going to go ahead and try to solve this, what to me would be the easiest way. I'm going to notice that all of these are divisible by 2. So I'm going to make my life easier right off the bat and just divide everything by that 2. So now we have W squared plus 20W minus 4,800 equal to 0. This to me looks like a completing the square. Now I could do that. If it factors, I could do that. But if you're like sitting there going, well, what multiplies to make 4,800? That's kind of a big number for me to sit there and try to do it by factoring. So I would complete the square on this, which means we would move the C over by adding it. I would figure out what is my perfect group, what is my perfect square here. X plus, how about W plus? Half of 20 would be, so we square that, 10 times 10 is 100. This we can do. We can now solve this, undo the squaring by square rooting. The square root of 4,900. And then subtract 10. And we will have two answers. W is equal to, about 70 minus 10. W therefore is equal to 60. Or W is equal to negative 70 minus 10. Or W is equal to negative 80. In the context of this question, since W is a distance, we did not go negative 80 miles. We went west 60 miles. And we went north 20 more than that, so 80 miles. So north, 80 miles. Okay? So I know these seem horrible, but they're not really that bad. Draw out the picture. You can be expected that you can have either one here with a Pythagorean theorem, or there's another one we're going to do next with an area model. The uniform border is being put around a pool, and the pool is 20 feet by 30 feet. If the border is to have an area of 336 square feet, how wide should the border be? Okay. Once again, I'm going to draw a picture. I'm looking at a pool right now here that is 20 feet by 30 feet. So it's 20 by 30, and then we're going to take this, whatever set width, and we're going to put a border all the way around this pool that has that set width. Okay? What we can do here is we can actually calculate the area that they've given us two different ways. They've given me the total area here as a number. 336 square feet is our total area as a number. That's 336 square feet. But then I could actually calculate the area of this border with a formula. So if the area of this border is 336 feet, could you find the area of all these pieces? Well, cut it up into some pieces. I know that this is W wide. This is also W wide. All of these are freaking W wide, right? The width should say constant. So what's the area of this piece? Well, W by 20, or 20W. That means the area of this piece is also 20 by W, 20W. The area of this piece is the same as the area of this piece, 30 by W, 30W, 30W. And last, what about all these little squares? Well, each of these squares is W by W, so each of these squares is W squared. So the area, the formula area for this is 1, 2, 3, 4 squares, 4 W squares, plus all 4 of these rectangles, 30, 60, 80, 100W. Take the area they give us as a number, find the total area, find the formula from the picture. We can now calculate what the width should be. I'm going to try like we did last time and see, can I divide out that 4? I know that that's going to go in there. This is going to go in, what, 25 times? And this is going to go in, I think it's, what, 84? Now, I don't know if this is going to, I definitely don't want to complete the square right now with that W in the middle being odd. I don't know if this is going to factor, but I'm going to check it. Numbers here aren't too bad. And if it doesn't, then I'm going to throw this sucker through the quadratic formula. But let's go ahead and see if they were nice enough to set this question up so it factors. What multiplies to make 84 combines to make 25. And the 84 is negative, right? Well, 84 is 1 and 84. Nope. 2 and 42. 3 and 28. There's a 25. 4 and 21. There's a 25. Which one does it have to be? Well, I need them to be opposite sides. So I'm going to need the top one where the 3 is negative and the 28 is positive, so that they add to make a positive 25 and multiply to make a negative. The 4 and 21, they'd have to be both the same sign, so that's not going to work to multiply to make the negative 84. So these are our numbers. So this does factor into, we had minus 3 and plus 28, setting each of these equal to 0. We get that W equals 3, or W equals negative 28. Which of these doesn't make sense? We are not setting up a border on the sidewalk of negative 28 feet. So we're going to do a 3-foot border. Okay? And that's kind of cool because you could check this out. If I did, if this was 3, this would be, change color so I can just see this. 3 times 3, this would be an area 9, 9, 9, 9. This would be 20 by 3, 60, 60, 30 by 3, 90, 90. Adding those up, 90, 180, 240, 300, 39, 18, 27, 336. It adds up to that total area if the border is 3 feet. And our last application is that they're going to give us basically, this is a formula that is going to simulate the arc of an object being thrown. Okay, so here we have a ball that's being thrown, and it follows the trajectory of negative 16t squared plus 64t. At what point will the ball reach 32 feet? What that 32 feet is basically an s of t. It's basically it's an actual height. Okay, so when will it reach 32 feet means I go to that s of t, and all I do is I put a 32 in there. I definitely don't like that A is negative. I don't like that it's a 16. If they were really nice, everything here would be divisible by negative 16. Let's check. I know that's negative 2. That's now a positive t squared. That is a minus 4. We got a winner. Now, I could try to add the 2 over. If I add the 2 over, and I try to solve that, that does not solve by factoring. So factoring is not my favorite choice here. What would I do? Well, since this is a 1 and since this is even, I would set up a perfect square, complete the square. T minus what? Half of that 4 would be 2. Squared means what do I put up here? This would give me t squared minus 2t minus 2t would be minus 4t, and negative 2 times negative 2 would be a positive 4. So we complete the square with a 4 added to both sides. So now I can solve this. Square root. T minus 2 is equal to plus or minus the square root of 2. Adding the 2, we get that t is equal to 2 plus or minus the square root of 2. Is it both answers? Do we toss out the negative this time? Right? We're dealing with time, so here's where I would go to my calculator and go, what is 2 plus root 2? What is 2 plus the square root of 2? So 3.41 approximately. That answer makes sense. At basically after 3 seconds, the ball is going to be 3.41 seconds, the ball will be at about 32 feet. What about 2 minus root 2? Let's see on that one. 2 minus at 0.586. Does that answer make sense? Can you have at half a second the ball reaches 32 feet and then later at 3.41 seconds it reaches 32 feet? I'll give you a hint. Yes, both of these answers are fine, and here's where the visual kind of comes in handy. We're tossing the ball and it reaches 32 feet, it comes up to a peak and then comes back down and reaches 32 feet at a second time. Okay? So the 2 times that it reaches 32 feet are at 0.586 and at 3.41. So the ball reaches that height twice. This is a parabola opening downward, and so it would reach that height twice. The only other question we would ask from this is when will the ball reach basically the ground? Okay, so when would this ball reach the ground? Well, what does that mean the height is going to be? Well, the ground, when it hits the ground, is a height of 0. So I'm going to take this formula, negative 16t squared plus 64t. Set it equal to 0. Make sure that's right. Negative 16 plus 64. Okay? How are we going to solve this? Some of you are going to run this through the quadratic formula. I wouldn't. First, I would definitely divide by the negative 16 again and get t squared minus 4t equals 0. You're like, now run it through the quadratic formula. I wouldn't. Somebody says, complete the square. I wouldn't. See, on this one, I could just factor it. Nothing complicated. These both have a common factor of what? And if I pull that out, I have 2 groups that I can set equal to 0. The first one gives me t equals 0. That means initially, where the ball is launched from, counts a ground of 0. At time of 0, the ball's at 0. Then, when does it reach 0 again? T minus 4 equals 0. So t equals 4. At 4 seconds, the ball reaches the ground again. Okay? So just like I said, some further applications, some formulas, just showing you how we use quadratics in real life.